Today we're going to talk about section 2.2 in our BJU Press Algebra 1 textbook. This lesson is about evaluating algebraic expressions. So let's just start with a review on the order of operations. Let's say we have 7 plus 3 parentheses 2 minus 8. So according to the order of operation, we would do 2 minus 8 first, which would be negative 6. Then multiply that by 3, and then add that answer to 7. So we should have gotten negative 11. Make sure you can also do that on your calculator. Our next problem is 12 minus 3 squared times 2. So the first operation we would want to do is 3 squared, which is 9. And then multiply that by 2, which is 18, and then we would have 12 minus 18, which is negative 6. Make sure you can also do that on the calculator and get the correct answer. Then we have 18 minus brackets or plus parentheses 6 minus 9. So remember, you do the most inside grouping first. So 6 minus 9, which is negative 3. 4 plus negative 3 is 1, and then 18 minus 1 is 17. So when you try to put this into your calculator, you're going to have to use a double set of parentheses. And so when you come to the bracket that comes right before the 4, that's going to be your first set of parentheses. So let's look at this problem. We want to evaluate when x equals 6, y equals negative 3, and z equals negative 1. So what we have to do is we have to use substitution, right? We have to let x be 6. So instead of saying x squared, we're going to have 6 squared minus 2y. But we're not going to say y, we're going to say negative 3. So 6 squared is 36, and 2 times negative 3 is negative 6. So we have 36 minus negative 6, which gives us 42. Our next problem is 3x plus y plus 2z. Go ahead and see if you can find the answer for this one by yourself. You should have gotten 13, because instead of saying 3x, we're going to say 3 times 6, which is 18, plus y, which is negative 3. So 18 minus 3 is 15. Then plus 2z. Well, 2z is negative 1. So that means we have negative 2. So 15 plus negative 2 gives us 13. When we try our third problem, x times y minus z, we have to do y minus z first. So y is negative 3 minus negative 1. That gives us negative 2 times x, which is 6, is negative 12. Next problem, we have 2 times xy plus 3z. So 2 times 6 times negative 3 plus 3 times negative 1 gives us negative 39. So all of that arithmetic can be done on your calculator to ensure that you get a correct answer. So evaluating an expression. Step 1 is we want to substitute the given values for the variables. So when you're evaluating an expression, you no longer want to have variables. You just want to have numbers. Step 2, we evaluate by following the order of operations. Example 1. Let's evaluate 3a squared minus b plus c cubed when a is equal to 1, b is equal to 4, and c is equal to 3. So remember, step 1 is substitution. We want to no longer have the variables a, b, and c. Well, we know that a is 1, so instead of saying a squared, we're going to have 1 squared. We know that b is 4, so instead of having minus b, we're going to have minus 4. And we know that c is 3, so instead of having c cubed, we're going to have 3 cubed. Now, we follow our operations. 1 squared is 1, and 3 cubed is 27. Now we do 3 minus 4 and plus 27, and we get the answer 26. Let's look at example 2. Let's evaluate x squared y z squared when x is equal to negative 1/2, y is equal to negative 2, and z is equal to 1/4. So we want to do x squared y z squared. So instead of saying x squared, we're going to say negative 1/2 squared. Instead of saying y, we're going to say negative 2. Instead of saying z squared, we're going to say 1/4 squared. So it's going to look like this. Now we need to distribute our exponents. And so we get negative 1/2 squared is negative 1/2 times negative 1/2, which gives us 1/4. Then we have negative 2, but since we're working with fractions, let's go ahead and write negative 2 over 1. And then 1/4 squared is 1/4 times 1/4, which is 1 over 16. Now let's see what cancels. 2 goes into negative 2, negative 1 times, and 2 goes into 4 twice. So now we have negative 1 over 32. So let's look at the definition of what we call a formula. A formula is an equation that it's going to express a relationship. So you're going to have different quantities, but the most important part is that all these different quantities have a relationship with each other, and that is what we call a formula. So let's look at this. P is equal to 0.433 height. P and H, P is the pressure from under the water, and height is how far underneath your water you are. So you see how the pressure depends on the height. There is a relationship between pressure and height. Another one that you might be familiar with is F is equal to 9/5 C plus 32. This is the formula that relates Celsius to Fahrenheit. In fact, it actually will convert Celsius to Fahrenheit. So formulas are just mathematical sentences that are used in all different types of professions. Let's review some math verbs. So these are symbols and notations that you're going to need to know. The first one is this. This is equals, which in math verbs is. And then we have this symbol, which is not equal to. Then we have this. It almost looks like an equal sign, but it's like a little squiggly. That means is approximately equal to. Then we have this symbol, that is a subset. And then we have this symbol, is an element of. So remember, the subset symbol is when you're talking about sets. A is a subset of B. So both of those things have to be sets. The next symbol that looks like a little bitty E, that is an element of. So you would use that when you're talking about just one thing. For example, 8 is an element of the natural numbers. So here we have this symbol. This is not an element of. We have this one, which is greater. And you're like, Miss Moss, how can you tell if it's greater or less than, or how can you read it if you don't know what numbers go around it? Well, remember, we read left to right. So since the opening, if you think about when we learned it in elementary school, the alligator is pointing to the left, right? So since we read left to right, that means the left is greater than the right. So we say that this is the symbol for greater than, which means this is the symbol for less than. And then we have a symbol for is at least and is at most. So those are confusing. So we have to think is at least. That means that's the very minimum it can be. So everything else must be bigger. The next symbol is at most, which means that everything else must be smaller than that. Let's review perimeter and area formulas from geometry. First, we have rectangle. The formula for rectangle for the perimeter is 2 times the length plus 2 times the width. Area of a rectangle is length times width. Then we have a square. The perimeter of a square is the formula 4 times S, where S is one length of a side. Then we have area of a squared, which is equal to s squared, or the length of a side squared. Then we have circle. The circumference, which is the perimeter of a circle, is 2 pi r. And the area of a circle is pi r squared. Remember, r stands for radius, which is half of the diameter, or half of the circle. Then we have triangle. The perimeter of a triangle is all 3 sides added together, a plus b plus c. The area of a triangle is 1/2 the base times the height. So let's say we want to find the perimeter of a rectangle whose length is 8 and whose width is 3. So first we look at our formula. P is equal to 2 times L plus 2 times W, where L is length and W is width. So we're going to substitute 8 for L since its length is 8 centimeters, and we're going to substitute 3 for W since its width is 3 centimeters. Then we follow our order of operations, 16 plus 6, and then that equals 22. Make sure you include your units, because if you don't, then you actually have the problem incorrect. Next example, let's find the area of a circle with a radius of 9 feet. So area is the formula pi r squared, and we're going to substitute 9 for r, and 9 squared is 81. So we get the answer 81 pi. I do not like decimals. However, you can remember that pi is 3.14, so you can do 81 times 3.14, and you would have 254.34 feet, because that's our units, and it's feet squared because we're talking about area. I would prefer that you do not give decimals and that you leave it. I would prefer that you had left it as 81 pi feet squared. So let's go over how to use formulas. First, we have to identify the correct formula. Then we substitute the given values for the variables in the formula, and then we evaluate the expression. That's all for this lesson. Make sure you do the problems that go with this section.